So this is the demo of the recovery from the Epoch Fallback Mode. Essentially, Epoch Fallback Mode is a safety mechanism that we have on Flow, which enables Flow to kind of continue to produce blog and be live, even if there is a problem with epoch transitions. It's triggered when an epoch transition, for whatever reason, fails. In that case, the network goes into this special mode called as Epoch Fallback Mode, or EFM in short. And the only way so far has been to recover from this mode so far has been to actually do a network upgrade, which is essentially what we call a spork, which is obviously very time consuming and has to have involvement from all of the node operators. What has been now implemented is a far better way of recovering from the epoch fallback mode, which completely eliminates the need of a network upgrade. The recovery is essentially through by sending a governance transaction to the chain. We're going to demo this new mechanism of recovery on testnet today. And the way we're going to do it is we're going to first force testnet to actually go into this epoch fallback mode, and then send the governance transaction, and then eventually see it recover from the EFM mode. So I'm going to now turn it over to Jordan, who's going to drive the process. Sure.
What is the metrics name? I want to look testing up on Grafana, which was tested.
The dashboard.
Yeah.
The mainnet dashboard, and then just change the network.
Testing? Okay.
And so while we're setting this up, just more context. There are 2 epoch transitions every day on testnet, unlike mainnet, which has 1 every week. One of the epoch transition happens at 12 noon Pacific, and then the other one happens at 12 in the night. I believe the testnet is actually undergoing one right now.
Yeah, it is. So it's in the epoch setup phase, which is going to end in about 30 minutes. Just going to be taking notes here of everything we're doing.
Yep.
So the first thing we're going to be doing in order to test EFM recovery is deliberately triggering epoch fallback mode. We don't trigger it, we obviously can't recover from it. So the way we're going to do that is by restarting the consensus nodes while they're in the middle of this kind of critical setup phase, while they're doing the DKG. And that will cause them, upon restarting, to basically see that they haven't successfully completed that process over the course of the time that's allocated for the setup phase. And then they basically just give up. And then they enter this safety fallback mode. So I'm going to restart them now.
Obviously, this is testnet, so the foundation runs the testnet, so we can actually do this restarts on the consensus node. For the mainnet, obviously, the foundation doesn't control more than 33%. So we can't do this on the mainnet. Like, we can't force the mainnet to do an epoch fallback.
Yeah, and we're going to do them one at a time because we don't want to have an impact on we don't want to have a substantial impact on the finalization. So waiting for the first one to successfully restart before moving on to the next one. Should see this pop back up to 7. This log will be log when we restart. So it's indication as we started. Should see it pop up on the metrics.
Those logs are essentially coming from our nodes, the testnet nodes, and we're looking at it on the Grafana dashboard, to which all logs are piped in.
Yeah, so because we only have 6 nodes, it's already, one of those 6 being down is already a non-negligible fraction of consensus nodes. So we even see a small here in the block rate.
Yeah, I'm not seeing this pickup, but since we see the logs, I'm pretty sure that census node 1 is back online. So next view. And we can see here, this is just the indication that restarting is basically successfully causing this node that's restarted to decide that it's not going to contribute to the DKG. So it's DKG started before, so it's skipping restarting the DKG for this stuff. All right, we see our consensus node come back online in the metrics, and our block production rate go back to the normal 2 blocks per second, which is good. We should see it dip again pretty soon for consensus node 2 and the subsequent ones.
So we are force feeding the DKG. The DKG is the distributed heat generation that happens across the axis, across the consensus.
On testnet, how many consensus nodes we need to bring down to trigger that?
I think it's 5,
We need to bring down 5.
but I'm just going to do all of them.
Oh, okay. And you do one by one, right?
So for context, the DKG, that's essentially, as Vishal said, distributed key generation algorithm. That generates a threshold signature key that the consensus committee would be using on the happy pass for the next epoch to generate the randomness, for instance, secure randomness that's available in Cadence. That's based on this threshold signature key. And so that's a special, collaborative key generation process to make sure that no individual nodes can tamper with it. And so if enough nodes or too few nodes participate in that, then we don't get this proper key generation process done within or before the next epoch starts. The system will notice that and then say, oh, whoa, we can't go to the next epoch because the new consensus committee wouldn't have a proper key set to generate the randomness, for instance. And so it will keep the old or the existing consensus nodes essentially continue running in like progressively sort of added small time intervals. Which we call then Epoch Fallback Mode, and that's or until there's a human intervention where the governance committee comes in and tells the system, okay, this is a new consensus committee, and this and then those are their keys. Yeah.
And so this is one of the reasons why the network could go into an epoch fallback mode, and they're essentially replicating that one reason. Yeah, to force testnet to go. There are other reasons, but this is obviously a simple way to force the network into epoch fallback.
Yeah, I think we had over the lifetime of the network, we had one instance where that happened, where a couple of the bigger node operators coincidentally sent their nodes into a reboot due to a normal maintenance cycle, and then the DKG failed on mainnet, and then we had to do. I mean, we kept the network kept being up in that epoch fallback mode, but eventually we had to do a sort of a network upgrade, so more or less a reset of the participation. That was because we didn't have that recovery mode yet. And so the epoch fallback mode is essentially just a disaster prevention mechanism, right? To give the humans enough time to kind of coordinate and reset the system so that the network just doesn't stop working at the end of the epoch.
There were at least two instances when the mainnet network went into epoch fallback mode, for which we had to do network upgrades, and then one on testnet as well. So this has been a reason for causing network downtimes, and this feature essentially helps us avoid those network downtimes in the future, especially since as the network grows, just the amount of applications running on the network and the scale of the network, it's difficult to coordinate an unplanned network upgrade on a short notice.
Which node are you currently starting, Jordan?
Okay.
Okay, great.
Eventually, the epoch phase will show.
We will see this. So later on, we'll see the transition into epoch fallback mode. When it is triggered, we'll see that in a phase and also in this metric here. That we won't see until about 1 p.m. though, when the epoch transition is scheduled. So 5 now. Yeah, one thing we'll kind of incidentally be able to see that's kind of neat is because our interventions are causing the block rate to decrease over a period of time. Not by much, by maybe 20-25% on average over tens of minutes. Cruise control, which is the system that that makes sure that epoch transitions always happen at a specific time. It's going to observe this error essentially and when it wants the transition to happen. And just going to do since it's 7 now, which is the last one. So we can see this here in the metrics where nodes are down, so we're having a larger percentage of timed out views. That means that we're kind of running behind schedule a little bit. And then in the controller output, we can see that there's this error that's appearing. And this is an error measured in seconds, like how many seconds off of our target timing are we? And then we can see that in the output of cruise control, it's going to output a target duration for each view. And we can see that that duration is going to go down because we're behind schedule. So we need to do views more quickly. So once we're finished restarting all the nodes, we'll see this block rate kind of spike up for a moment. And that will be cruise control bringing us back onto the correct schedule.
But the cruise control is agnostic of the fact that the DKG has failed. It will just keep trying it. Never give up trying to ensure the epoch happens at the same time.
Yeah, cruise control, like regardless, the DKG is for the next epoch, but we're like transitioning through the views within the current epoch, and the current epoch has a target end time that we want to hit and a target view, like final view, when that should happen. So regardless of what happens now, we still try to hit that time. And then either we go into the next epoch, which also has a target end view and time, or if we're in EFM, we add these extensions, and each extension also has a target view and time.
Okay.
So cruise control just like takes that view and time tuple, and it just tries to make that happen.
So essentially, it's carrying over from the existing epoch, which is running into epoch fallback mode. It will try to carry along the same timing, same number of views per second, ideally. So it's kind of mirroring a perfect clock, or trying to mirror a perfect clock as best as it can, right? And if you're running past, the sort of threshold for actually the next epoch transition will just sort of keep running at exactly the same pace until we eventually make the epoch transition.
Yeah. So we've now restarted all the consensus nodes. And yeah, we should see this little bump in the block rate that I mentioned, but otherwise we're not really going to see anything until about 1 p.m.
Time to get coffee.
Time to get lunch or coffee. Yeah.
I have a meeting at 1. I'm gonna miss this.
No. Like you're sitting at a race, right? And then right before the first starts passing the finish line, you're like, I have to go.
But at 1, we just go back to the staking phase, right?
No. So at 1, what we'll see is this EFM metric is going to say we've triggered epoch fallback.
Oh, right. Then we do the transaction.
Do the governance transaction.
Yeah.
When we move into the staking phase depends on how long what's called the epoch extensions are. And on Testnet, they're set to there's 100,000 views.
So
it's kind of actually probably too long. We should make them shorter, but that lands us about kind of in the middle of tonight. So once we send the recovery transaction, in the middle of tonight,
but as soon as we send that transaction and everyone received that transaction, the phase will go back to the staking phase, right?
Yeah.
Okay. And then you said the 100K is specified in that transaction or specified in the somewhere else?
No, so no, without any transaction, we'll add an extension, which is 100,000 views. And then,
22 hours roughly. I tried to
it's,
calculate that.
it's like, it's 2 blocks per second.
Oh, right, we're running faster, okay.
So no governance transaction, no recovery, we just keep adding those extensions. And each extension is an opportunity for the governance committee to send the transaction and do a recovery.
Oh,
And if they do a recovery in an extension, then that basically takes their configured recovery epoch and like plops it at the end of the most recent extension. So you still actually go through the entirety of the extension.
okay.
And the extension is 12 hours itself?
14 hours, I've just,
Got it.
Yeah, we just used the same. I didn't actually think that through very much. We just used the same values for mainnet testnet.
But so then if it's 14 hours, then the recovery from Epoch Fallback would happen 14 hours later, right?
Yeah, at 2 a.m.
At 2 a.m., not at 12 a.m.
Not at 12.
So that 100K transaction basically defines how often we will recognize the governance transaction. Yeah, right?
How often we will recognize it?
Yeah, so when we hit at the end of this epoch and we trigger the fallback, to trigger the emergency epoch, we will extend for 100K block, right?
Yeah.
And then before, and if this is end and no transaction, governance transaction was sent, it will extend another 100K, right? And then at the end of 100K, no, in the middle of this 100K, let's say 50K, there is a governance transaction. Does it triggers the phase to change from the fallback phase to the staking phase right away, or does it
No, it's only after.
until the end of the 100K, right?
but what happened, you're thinking the right way. Internally, this is happening. It will recognize, oh, now I have a proper next epoch, which is valid, and it will say the next epoch is committed.
Okay.
So internally, it will recognize, now I have a next epoch, and I'm like, we're no longer adding extensions. This epoch now will start at this time. You know, even though it doesn't start right away, but it will start at the end. And, you know,
Right.
it's like, so halfway, quarter way through that extension, we can already commit to the next epoch. Or if the governance transaction is rejected, we have a few sanity checks there, right? Typo or something like that. And we'll say, no, I reject your governance transaction, and we'll just stay in that mode. And then you can send a new governance transaction and see if that's accepted.
This 100K, where is this specified? Because if this is specified for too long,
Yeah.
and then the governance will still cannot transit the epoch.
I think that is also a parameter which we can also change via other governance transactions. I think so, right, Jordan?
Yeah.
Or if we hardware that.
No, it's in the protocol state,
Mhm.
the extension, you mean, right?
How long that is, yes.
Yeah, it's in the protocol state. There isn't a service event for it yet, but it's pretty sure.
Okay, so we have the technical underpinnings to change it. We just don't have the hook yet. You actually do change or the information package to change it. Okay. Correct.
Okay. Cool, sounds good.
Yeah, so I said there would be a jump in the block rate, but actually, so the error has gone back to 0, which means that cruise control has successfully compensated for the extra failed views, but it's kind of hard to see that.
You can see that a little bit further down if you go to the next figure below. Yeah, exactly. So the orange yellow marked area, that is how long it waits, like under to kind of make the desired timing, right? And you see it to the very left, it waited around 400 milliseconds, right? And then when the nodes keep like went down, and some of the nodes then didn't propose. You see that the other nodes waited less time to compensate for the first node, or the offline nodes not proposing, and so it didn't accumulate beyond the time where it didn't wait at all. It was sort of managed to, since it was one node at a time, it still managed to kind of compensate it largely on the fly.
But yeah, so that's all for this part. Matt, do you have any questions or anything you'd like us to cover?
No, nothing for me. This has been very fun to watch. Very informative.
Okay.
All right. Who can start? So this slide basically shows what we have done so far and what we're planning to do. So yesterday, on 6th March in the morning, 11 a.m. Pacific, we triggered EFM on testnet by restarting some of the consensus nodes to make it fail the DKG during the setup phase. Eventually at around 1 p.m., testnet actually went into EFM, which is what we wanted. Then we took a break because the next epoch transition was scheduled for 12 a.m. in the night. So we obviously didn't want it to be awake during that time. So we are reconvening now, 7th March, to essentially submit the governance transaction. And the governance transaction is the new way of recovering from the Epoch Fallback Mode. And once we submit that, later in the day at 4 p.m., we should see the testnet actually recover from EFM. I will now let you try it, Jordan. Stop presenting.
Okay. Sounds good. So the first thing I'm going to do is run through some of these parameters with you, Alex, to make sure that they look correct and to double check them. Okay. Can you see that? All right.
Yep.
So we are going to run this command. With the new util that we built, which is named util extra logging. These are all fine. Collection clusters, we have 2 collection clusters.
Jordan, do you mind talking a little bit about the util and some of the important parameters?
Yeah. So this utility its essential purpose is to output the arguments that will be passed into the governance transaction. So it's a way to kind of validate that the parameters are correct and compute some of the parameters that are more complicated. So we pass in some information here that basically lets the utility figure out what the governance transaction to exit from EFM should look like. So these first 2 are an access address, which is going to use to retrieve the most recent protocol state snapshot for the network. And then most of these other ones are kind of determining how we want the recovery epoch to look like. And the recovery epoch is the epoch that we're going to enter into after we successfully exit EFM.
Can I ask a question? So the second parameter says as access network key. Is that the public key from the access node?
It's the public key so that we have a authenticated connection.
Right. So no one can sort of feed us garbage or do a man-in-the-middle attack and feed us garbage, which we then use to kind of essentially force the network into or force the network to adopt for the next epoch, and then mainnet would go down if those parameters were corrupted. I see. Thank you.
Yes, that would be bad. So yeah, these are the parameters that I want to validate. And this is kind of good practice because on mainnet, we would need to be careful about the timing. Most likely, we would want to get back onto our schedule. So the recovery epoch counter is the easiest one. This is just one greater than our current epoch counter, which is 2065. And then the other ones are the duration, the length, and the staking phase length. So before the meeting, I've gone through and found the final view of the current epoch extension. What that means is it's the last consensus view for which we have kind of decided that we'll move through as a network. So it's the earliest point in time at which we can enter the recovery epoch. So for us, it's this big long number right here, starting in 283. And then the extension end time, we have some tooling in the metrics that allow us to calculate this too, although it's not directly exposed. But I calculated it about 30 minutes ago. So at that time, the hours to epoch end was 6.63. Now it's a little bit lower because time has passed. But at that time, at 10:07, it's pretty easy to compute roughly what the end time will be. It's about 4:45 p.m. Pacific time. So I have put those into a table here. So this is the final view. This is the end time. The view rate on testnet is 2 views per second, which is pretty much corresponds to 2 blocks per second. And this is something that the Human Governance Committee will have to decide. For the recovery epoch, when do we want that epoch to end? Usually we'll set this in order to kind of get back onto a schedule that we've been on previously. So for testnet, we have 2 epochs per day, and they're at about 12 p.m. and 12 a.m. So both 12-hour epochs. So for this one, I'm setting it to the next time slot, kind of in that schedule, which is 12 p.m. on Saturday, tomorrow. And then we need to figure out what the recovery epoch's duration is going to be in order to get to that end time. So if the recovery epoch starts at 4:47 p.m. and we wanted to end at 12 p.m. on Saturday, then it's just 12 hours plus 7 plus 13 minutes. So 19 hours and 13 minutes. And that is 69,000 seconds. And then in view terms, since we're running at 2 views per second, we want just double the number of seconds in view terms. Okay, so it's this minus 12,000. So 1263, 60. All right. I think think this all looks good. 19 hours. Six nine 180. All right. So duration. Duration at 6 9 180. Length in terms of views. One 38360, which is double the duration. And the staking phase length is 126, which is 12,000 less than 138. Okay. Does this all look good? Access, Flow Testnet, 2 collection clusters, epoch length, staking length, recovery duration, and the recovery counter.
Yep, looks all very good to me.
All right. Okay, so now we will just going to remove the old version of this. Put some extra stuff in there. Okay. So now we'll use the utility tool that we have to generate the transaction arguments for the governance transaction. Okay.
The warnings are just essentially extra nodes that are no longer part of the network.
Yeah, so I'm just going to go through here and check everything.
Sure.
So this is all of the nodes that we read, and like Vishal mentioned, this includes some nodes that previously were running on testnet but no longer are, which the utility tool should deal with. So it's going to warn for each of those nodes. Is normal. And then we're partitioning 0 partners and 14 internal nodes into 2 collector clusters. Looks good. And when we construct the root QCs, we want to see a reasonable number here for the number of signers. So there's 7 nodes per cluster and there's 7 internal signers. So that all looks good too.
Very nice.
Okay. And I'm going to copy that file over. Okay. And now we can check it again. Cover epoch counter, These are going to be the view configurations. So 66400, I think that's just the start view. Yeah. Start view, staking end view, and then the final view. Six nine one 80 is the duration. And then this is the Unix timestamp for the desired target end time. Yeah, we got it pretty close. Saturday at 11:59. That should work. All right, and then here is the cluster assignment for the recovery epoch and the cluster QCs. Five voters. Does that make sense?
Sorry, I was just answering a Slack message from Vishal in the background. 5 voters for what?
For the cluster QCs.
Yeah, that makes sense because I think the well, so we have 7, right?
We have 7.
7 nodes per cluster. So I'm wondering if our QC generation utility just stops once it has enough signatures.
It does, but is 5 enough or is 4 enough?
5 out of 7. So 5 out of 7 is 71%, and 4 out of 7 would be 57. So that wouldn't be a supermajority. So it does the right thing.
Okay, perfect.
Thanks for
Cool.
noticing. I'm glad you checked.
And then here we have the DKG. 7 DKG keys and the DKG index map with 7 entries. And the list of authorized node IDs. Okay, so we're back recording again, and we've just validated these arguments in EFM recover args.json.
That's me.
And now I'm just going to grab transaction that we're going to use. Okay, so we're sending a transaction, and we can just specify we're sending it to testnet. Signer is going to be the testnet staking account. And the arguments that we're passing in are going to be pulled in from this file. And then I just need to get this transaction script. All right, so this is the new recover epoch method. And I think I have all these contract addresses set up already, so I don't need to manually change those. Let's see. Mr. KC, DKG, Epoch. Staking. Yeah. Okay. Okay. Moment of truth. Need CF3. Okay, that's fine. So we need to instead run this with the testnet service account. Make sure everybody still looks happy. Okay. Send on testnet service. Okay, that looks fine. So I'm going to try sending it again now. Sending the recovery transaction. Okay, there we go.
All right. So we have essentially now submitted the governance transaction, which will ensure that the testnet automatically recovers when it attempts to do the epoch transition later in the day, correct?
Correct.
Okay. And we obviously did this on testnet because we have the keys for the service account, but obviously on mainnet, we would need a governance committee transaction where people multi-sign and then we submit the transaction. Okay, so the next step is to reconvene at 4 p.m. Pacific and see the network actually recover.
Yeah, it'll be more like 4:45.
Okay.
But yeah.
Okay, great. Then
Okay.
we'll reconvene then.
All right. See ya.
Well, thank you.
Bye.
Okay. We're back recording again.
Yes.
All right. So no, that's just the AI.
Just a
Yeah, so we're back here and I have this zoomed out to the last 6 hours so we can see what happened before we took a little break, which is that we sent the recovery transaction at around just before noon Pacific time. And you can see that in the metrics, this is showing up as us exiting fallback mode immediately and us entering what we call the committed phase immediately, which means that the next epoch that we're about to transition to is committed, and we're ready to transition into it when we get to the right view. And we should be seeing once this ticker here, hours to epoch end, gets to 0, we should be seeing us move into the recovery epoch, and then the network will be essentially fully back to how it was before. And then it will, after this point, proceed automatically with epoch transitions like it normally does. Hey, Alex, you're just in time.
Hey. Oh yeah, you have already. Oh no. Before you jump in, I noticed that you could very nicely see that in our metrics after you submitted the governance transaction, that it went from currently being in EFM to next epoch is already committed.
Yeah, I just talked through that before you jumped on, and yeah, so we can see it all happening now. So it says setup phase, which is kind of a metrics bug. It's taking the average of all the phase values, and we just switched from numeric value 3 to 1. So there's a short period where it thinks that means 2, but really it means 1, which is the staking phase. And then we can see the epoch counter bump up, and we can see all of our timing metrics bump up as well. So we're entering the new epoch, and we're adding another span of time, which we're going to transition to. So this is kind of adding hours to the counter until we have the next epoch transition, which is what we see in all these epoch timing metrics here.
And I also see the EFM shows normal operations now. It was showing epoch fallback mode earlier.
EFM shows normal operation. Yeah, so that we actually entered normal operation as soon as we submitted the recovery governance transaction.
I see.
But yeah, so now everything is basically back to normal automated operating.
Amazing. So we have essentially recovered from the epoch fallback mode.
Exactly. No spork required.
No spoke required. Saved us easily several hours of preparation, and then maybe at least half an hour of network downtime and all the pain associated with it.
Yeah.
Ooh, that's amazing.
Yeah. Do you? I'm not sure if you've done that before. If you go back to 11:26, in your oh, actually, yeah, interesting. Yeah, no. Sorry, I meant if you here. Can I quickly share?
Sure. Yeah.
All right. Oh. Yes. Okay. Oh. Yeah. So what I've said is I've essentially selected the last 7 minutes before we submitted the governance transaction, right? And what you can see here is that for EFM, it says we're in fallback mode, and the epoch phase says fallback phase. And so if you go 1 minute forward, that's when the governance transaction was accepted. It now immediately, the metrics already show, oh, we've accepted the governance transaction. The network now has a proper epoch to transition to, and that epoch is committed already. So the protocol state, we see that in the metric that the protocol state has successfully accepted the recovery transaction. Yeah, and then, it says, oh, 5 hours, 5.3, or yeah, 5 hours 20 minutes until the epoch switchover happens. And that, since we have epoch committed, that indicates we're transitioning into a proper epoch, essentially leaving the fallback epoch extensions.
Got it. Got it.
Yep, that's all I wanted to quickly share.
Okay. I just wanted to also share the slide that I had earlier. So let me just quickly bring that up. Yeah, so just wanted to recap what was demoed. Essentially, what we demoed was the automatic recovery from the Epoch Fallback Mode on Flow Testnet. So yesterday, we forced Testnet into an Epoch Fallback Mode by forcing restarts on some of the consensus node to make the DKG fail. After that, Testnet actually did go into Epoch Fallback Mode as expected. Then the next epoch transition obviously didn't happen because it was in that mode. And then today morning, we submitted the governance transaction to ask the network to come out of the epoch fallback mode. And then just right now, the network actually did come out of epoch fallback mode as expected. So that concludes the demo. Thank you so much, guys, for joining. All right. Thank you.
Thank you too.
Cool. All right.
Amazing work, Jordan and Yuri, and yeah, you guys.
Yeah,
That is
very exciting to see it all working with no hiccups.
Yes.
Minimal hiccups.